Okay, now you need to calculate the bandwidth of the system. For that purpose, you first of all recall the cursor and measure the maximum decibel. It's actually 46.77. Okay, and remember that the bandwidth is the maximum allowable ranges of the frequencies that are able to be greater than in which the output is above the 70 percent of the input. That means that it's the range of the 3 decibel, that all the ranges are above the 3 decibels. So in order to measure the that 3 decibel, that means if I subtract the 3 decibel from here, from 46.77, it will be approximately 43.77. Okay, then by using this cursor number 2 and keeping the cursor number 1 at exactly 180-degree phase difference, and moving this cursor 2 in such a way that this decibel is difference is about minus 3 dB. So that is the point where we will get the low frequency value of our system. So this is 3.08. Let's tune it further. It's now 3.06. Okay, fine. And similarly, for the high value of the frequency is exactly at the 3 decibel units from the high cutoff frequency side. That means this region is the low frequency range, and this region on the right side is the high frequency range. So we can easily move this cursor toward the same axis that matches with the cursor of the cursor 1. So now note down these values. The low frequency is 3.168 megahertz, and the high frequency side is the 3.168 megahertz, and the low side is 310 hertz. So if you take the difference, you will be easily able to find the total bandwidth of your system. Okay, now in the next point, we would like to arrange the 3 controlling capacitance. One is the input side capacitance, output side, and the bypass capacitance in this following way. This can be easily done by tracing the AC sweep graph in which you are actually changing the frequency, and then find the points using the slope intercept slope equation, or whatever you like to say, the total slope of the line. You will be realizing that in the first case it's actually minus 20 dB, and after the next transition it's become 40 dB, minus 40 dB, and in the third, played by the bypass capacitor, it become minus 60 dB. Okay, now what you have to do is now from this view, you can easily realize that from this point to this point the slope will be different, and after that from this region to this region it's different, and from this point to this point the slope you can say the decibel per decade will be different. That means if there are 3 capacitors, there will be 3 different sets of slope. Okay, what you need to do is to find the slope of these 3 different capacitors using this low frequency analysis, and just trace the location of the frequency and the slope point, and compare it with your BJT analysis, whether in the FET is it same or is it different. Okay,